Hello to all you fabulous mindsetters. Welcome to Into Exam School Revision. I am Ulungile Mazibuga, and yes, on today's show we are all about physics for you grade 12s out there. So I hope you guys are amped up for today's show. I hope you guys are ready. Remember, we are on Facebook actually. That is where you'll find us. Let us know anything. That is www.facebook.com/mindsettv. If you guys have any additional questions that are more lengthier, send us any emails. That is questions@learn.co.za. And as usual, we've got our favorite teacher in the studio. You know we all love her, and everybody out there loves her. And I'm not talking. I'm only talking about Tracy.
I like you. You can stay.
I can stay. Yay. Thank you so much.
Anyway.
Remember,
yes.
guys, we are on Facebook. That is where you can simply find us. Let us know anything that you guys want us to assist you with. That is www.facebook.com/mindsettv. And if you have any other additional questions that are longer, that need a lot of explanation, let us know in our emails. That is questions@learn.co.za. Tracy, you good?
I am. We have lots to get through today, guys.
Okay.
Seriously, we have so many questions, and I hope we've got our turbo boost on today, actually. So we're going to see how much we get through. But these are great questions, and it's bits from everywhere. So let's go. Okay.
Go.
Now, the first question, I actually started this a couple of shows ago, and we ran out of time. So we're going to finish it, okay? It's a vertical projectile motion question. And what we had is the velocity time graph shows the motion of a ball as it's thrown vertically upwards from the balcony of a building. It takes 0.5 seconds for the ball to reach its highest point, and then it falls past the building and strikes the ground. Now, the first thing they wanted to know was, what is the value of the gradient, which is 9,8 because it's in free fall, and the time to get to the top of the building again was 1 second. So the time to go up is equal to the time to come down. Now, we're going to go and look at where it says to us, use only the graph and not equations of motion to determine the maximum height. Guys, this is really, really important. You need to read questions carefully here because you have enough information on the graph to use equations of motion, but you are not allowed to. If you use equations of motion, they will give you naught, even if you get to the right answer, because we're stipulating method. And you have to do it the way we ask you because we're testing a skill. So remember, science isn't just about getting to the right answer. It's about how you get to the right answer, and that's the important thing for us, okay? So we're now looking at how to find let me just see, it's not this one? No, it's this one. Okay, there we go. How to get the height, okay? So we're looking at the highest point. So that means, and I've actually done it here, we've got to look at the area under the graph, okay? Now, even though I want height, I'm looking at area. Area is a gradient, we're actually looking at displacement. Displacement is a vector, up was negative, okay? So that's why I get negative 1,225. It's exactly negative 1,225, which then I change to a positive number, okay? I'm going to leave the 3 decimal places. Your exam says round off to at least 2 decimal places, okay? That means minimum 2 decimal places. The more decimal places you round off to, the more accurate your answers become, okay? But the 1,225 I'm going to leave because it's exactly that. It makes life a lot easier. Okay, so now they say to us, calculate. Ooh, look at question C. Calculate what here? Using equations of motion. Now they're saying to me, I can't use the graph in the traditional sense of going area or gradient. They say using equations of motion. The velocity x with which the ball strikes the ground. So now I look at this and I go, well, I want this velocity, okay? And I've got to now look at the information I'm given. I'm going to go back here because this is going to be easier. So from my graph, I know initial velocity, very important. I know time. I know velocity somewhere in the middle, but I guess I could use that as well because then I know this little disk part, and I know acceleration due to gravity. But I want to try and make as few mistakes as possible. So I don't really want to use this time and then use this as my initial, because look what we can do. Okay, I can work out that, because that's the final velocity. I know my initial velocity is minus 4,9. Here's where life gets interesting. I want VF, okay, A, now watch here, is positive 9,8 meters per second squared, okay? My gradient to my graph is positive, all right, and I saw from the graph that up, my original direction, was negative. That means down is positive, and I can't change that along the way, okay? And delta T is the 1,7 seconds. Now, this is quite nice because it means I can use this equation. VF equals VI plus A delta T. So I've got 4,9. So it's minus, minus, put the minus in, plus 9,8 times 1,7. Okay, so if we put in our calculators, let's put that there. So I've got minus 4.9 plus 9.8 times 1.7, and I get 11,76, and I get a positive answer, which is exactly what I expected because it's going down when it hits the ground. So that's quite important, okay? I get a positive answer. We're all very happy. Okay, next part of this question was, there we go, let's see. That's the first part, so I've got 11,76. Now they want the height of the balcony above the ground. There's so many ways that you can do this, but I want to encourage you to do this in one step, okay? So I'm going to go back here, and I'm going to go back to my information that I used to get VF, and I'm going to go, well, now added to this, I actually want delta Y, okay? There's lots of equations I could use. I can use VF squared equals VI squared plus 2A delta Y, or I can use delta Y equals VI delta T plus a half A delta T squared. I'm going to use this equation, okay, because if I've worked out VF wrong, then I'm going to carry that error down into the next question. I don't want to do that. Let's just make life easier, okay? So VI is minus 4,9. It was 1,7 seconds. That's 9,8. There we go. And 1,7 squared. Don't forget the square. That's quite important. So we're going to have minus 4.9 times 1.7 plus, I'm just going to put in brackets easier, 0.5 times 9.8 times 1.7 squared, close my brackets, equals 5,83 meters. I got a positive answer because it's below my starting point. It's exactly what I expected because down was positive. Yay, not so bad. Okay, then, sketch an acceleration versus time graph. So, there's the graph, and now we need to sketch the acceleration versus time graph. You have to see something about this graph, and this is so, so important. It is a single line. My acceleration doesn't change. So important, even with bouncing balls, it doesn't matter. Your acceleration stays the same. They put this in to see whether you understand that, okay? Secondly, they're also trying to test here whether you understand which direction was positive, because that does make a difference here. So we know, we said down is positive. We've done that the whole way through because my initial velocity was negative. Acceleration due to gravity is 9,8 meters per second squared, and it's positive. So on the graph, this is what your graph will look like. Okay, we're simply going to draw, and I'm going to make it a nice line so you can see it. No, that's not what I wanted. No, we're just going to draw it freehand. A straight line, which ends at 1,7, and this is 9,8. That's all you need to put in. Please be careful, grade 12s. When it comes to a sketch graph, you still have to put labels in, and you still have to put units to your labels. If you don't put those in, you will lose a mark. But when you do put them in, you don't get a mark for them. So it's a little bit of negative marking here where they go, well, we needed it there for completion, for it to be complete or whole, whatever you want, whatever word you want to use there, but without it there, there's something missing and your graph doesn't make sense and it's just a bunch of lines, okay? This would only be worth 2 marks, so please don't go and spend 4 million minutes or hours or whatever, slight exaggeration. Don't go and spend hours drawing this nice, beautiful, accurate graph. It's not what they wanted, a sketch. I'm looking at the shape and I'm looking for important values if you know them, okay? Great. So, we're not going to take a break just yet. I know your little brains are, but we're not. We're going to move on because now we're going to do some momentum. Yay! Okay, so Canon. Love these questions because they tend to get quite violent, but let's not go there. There's only so many things we can ask you. So a cannon has a mass of 1,250 kilograms and is, oh, now look here, is 1,000 times heavier than the cannonball. It's all right. That fires during a training exercise. The cannonball leaves the barrel at a horizontal velocity of 8. So that's the velocity of the cannonball. And then we've got a picture, okay? So we've got our cannonball coming out, and we've got our cannon. Brilliant. First question. The cannon comes to rest, important, comes to rest 1 second after being fired. So there's 2 sets of motion here, grade 12s. There's the moment when it gets fired and the cannon and the ball separate, and then there's the moment when the cannon moves backwards and then the cannon stops. 2 separate sets of motion. We have to deal with them separately, okay? First thing, define in words the term impulse. Guys, this is really important because here you lose marks on silly things with this because you lose marks on definitions that you really shouldn't, okay? I know, now watch here, impulse is F net delta T, and we know that it's equal to change in momentum, okay? But the definition of impulse is not that it's equal to the change in motion. The definition of impulse comes from the first part of this equation, from F net delta T. So we would go impulse, okay, is defined as the product of the net force acting, that's an A by the way, acting on an object and the time for which it acts, okay? So we want the fact that impulse is net force times time, okay? Do not say it's equal to the change in momentum. I know it's equal to the change in momentum, but the fact that it's equal to the change in momentum is what we use in calculations, okay? Great. So, next question. Calculate maximum velocity with which the cannon moves backwards. This is part of the separation moment. That is conservation of linear momentum. So, watch. We now go, so this is B, question 1. Okay. I wanted it to be blue, but anyway. Sigma PB4 equals, remember that's the sum of the momentum before equals the sum of the momentum after. Beforehand, we have the cannon and the mass of the ball, and they're one object. Afterwards, they're 2 objects. So far, we're all okay. Initially, the ball and the cannon aren't moving, they're stationary, so my initial momentum is 0. Excellent, not a problem. The cannonball, they told me, was a mass of 1,250. We want the velocity. Oh dear. Now comes the fun part, because I need the mass of the cannonball. So when we go back to the question, we go, well, the cannonball is 1,000 times lighter than the cannon. So watch. The cannon is 1,000 times the mass of the cannonball. So that means the cannonball is going to be 1,250 kilograms divided by 1,000. So it's 1,25 kilograms. Don't get freaked out about the fact that you weren't given the mass. You have to work it out. Okay, it makes this a little more difficult. So let's go here and we go fine. This is 1,25. I'm going to say 80. What I've actually done by default here without actually working it out is I've said that the ball's motion is my positive motion. Okay, so I'm going to put minus 1,250 times the velocity of the cannonball here. And let's work out what, sorry, that's the cannon, sorry, times 80, which gives me 100. Okay, so the velocity of the cannonball, okay, because now I'm going to go 100. Okay, 100 divided by 1,250 gives me 0 minus 0,08. But now we need to put it as a positive, and if we made the forward direction positive, because that was the direction of the cannonball, I'm going to say that that means the cannon is going 0,08 meters per second backwards. That's fine. Okay? Or you could say away from the cannonball. Okay? So, I think we need a break.
You're exhausted.
Yeah, but that's just because it's midweek. I'm not used to doing this in the middle of the week. But yes, it's time for a break.
Okay, guys, so Tracy's exhausted. I'm sure you guys are a little exhausted. You cannot be exhausted more than Tracy is. So we're going to take a quick ad break, and when we come back, there is still a whole lot of physical science that needs to be done. So be ready. Go drink water, actually. Go. Go now.